Dear Sigurd, dear people from Asplan Viak, thank you very much for the possibility to show you some projects of our office. It's interesting to hear a bit the points that you were explaining about building in Norway. It seems to be a kind of a bit different approach also concerning the contractors, but we're gonna talk about this later. I made some cards because I don't know all the English words, so I hope it's gonna work this way. Yeah, my name is Paul Schmidt. I'm the CEO of a small architecture company in Switzerland, Atelier Schmidt. The company was founded in 1988, and at this time my father founded the company, and since 5 years I'm running the company. And our office, or the architecture started in the 90s with questions about how to reduce the heat consumption of a building, and then we started building houses with a lot of EPS or with a lot of glass wool or stone wool, and then we realized that this is not a solution. You can reduce the consumption of a house with using EPS, but it's not going to solve the gray energy problem. So we started looking into building with straw, and in 2001 we could build the first load-bearing straw bale house in Switzerland, and it was the first building, and afterwards people were kind of a bit probably waiting to see what is going to happen with this building. After these 5 years we started building more and more straw bale houses. But we also do normal houses, but the people come more often for the straw bale houses. So first of all, why do we actually started building with straw? This is a kind of a simple statistic that tries to show how the building standard nowadays is, and what are the important points of it. So first of all, we have the creation energy for the building itself. So it depends what materials you use. For example, if you use concrete and EPS, this is going to be really high. If you use timber and straw, this is going to be really low. This is one factor. The other factor is the operating energy of the building. So the more isolation you have, the less energy the building needs, and the more photovoltaic you use, the more energy the building itself can produce. And the third aspect, which is probably the most important one. Sorry? Okay, yeah, now, sorry. The third aspect is the lifespan of a building. The most ecological buildings are always the buildings that are never torn down, because the moment you tear down a building, you destroy all this energy that was not only put in the construction of the building, but also the energy the building needed itself for all this time. So our goal is actually, or our vision. Where do I have to point there? Okay. This is kind of our vision. We try to reduce the creation energy as much as possible by using alternative materials that don't use a lot of gray energy. We try to build buildings that produce more energy than they use, so that, for example, in this statistic you can see after 25 years, and this is always our goal, that after 25 years the whole the creation energy that the building needed is built down, kind of, and after 25 years this building is net zero CO2. So the building after these 25 years, it consumes more, or the CO2 level just goes down and not up anymore. And the most important part for us is also the 25 years. We want to build houses and constructions that are not torn down after 50 or 100 or 200 years. We try to build buildings that prolong for a long time, and this is only possible with an architecture that is cultural based, cultural rooted, and that gives you a lot of possibilities to reuse the building itself. Only if the buildings seem usable for the inhabitants, then it's not going to be torn down. Otherwise, it's going to be torn down. And this is also the most important part, because it's the architectural part and the element of architecture in the sustainable idea. So it's not just work, not just using ecological materials. If the architecture is bad, then the building is going to be torn down after 20 years or whatever. So why did we start building with straw? We compared all the materials that we could use from the point of view of gray energy, and this is just a comparison. Sorry. For example, for 1 square meter of EPS isolation, I don't know, do you say EPS in English? Yes. Okay. You need around 900 kilowatt hours to produce this 1 square meter isolation. For stone wool, you need around 220. For glass wool, you need around 90, and for cellulose fiber, around 63, and for straw in general, about 20 kilowatt hours per square meter. And it's not only the gray energy that it takes, but it's also the CO2 that is inside the straw, that is kept into the straw, that is also an important factor compared to the other ones. And you also see the heat transition coefficient from all these different types of isolation is similar, but straw is really close to the other industrial produced materials. And this material, like Mr. Gunnarsson said before, it's just on the field. You can take it from the field. It's not nothing that is processed more than the thing that comes from the field. So this is a picture of a straw bale. So I just wanted to show that everyone knows what we are talking about. This is a small-sized straw bale. There are also bigger ones, but this is kind of the straw bale size that we work most with. And we heard before about quality management. For example, the straw isn't a product that you're gonna receive from a company that is specifically working with construction. The construction company or the contractor is going to say that he doesn't have straw, or he doesn't know where to get it. We also had a lot of these discussions in Switzerland. But the straw itself, every farmer knows where to get his straw, and the contractor just doesn't know that there is a whole agricultural logistics for this product that they don't know of. And this agricultural logistics is really really good, because every farmer can call today to the contractor, and he's gonna get his straw tomorrow. So this is but the problem is these are two different logistics. One is the agricultural logistics, and the other one is the construction logistics. And also with the quality management, a farmer knows how a good straw bale should look like, and no one is gonna give the farmer the guarantee that this straw bale is gonna I don't know, has these and these quality aspects. The farmer just knows it, otherwise he's not gonna buy the straw bale. And also this is also a highly industrialized product. The sizes are perfectly matched for the truck size. So the truck size is always 250. So you can always put these straw bales on a truck. And the price is also really low. So for such a straw bale in Switzerland, if I order the straw bale, it's about 10 euros to get it to my home. And then the cost part is taking the straw bale and putting it into the wall. This is the pricey part. But it's a bit problematic also. Like I said, in Switzerland, we often have to explain to the contractors that this is not a bad deal for them too, because it's not a lot of work to do it, but they need a bit of persuasion to do it. There are mainly three different types of constructions when you're building with straw. One is the frame construction, where you use the straw to fill the frame. And there is the other, the second type, where you build up the straw bales kind of like bricks in front of, for example, a timber construction, or also another kind of construction. And we mostly use the second type we use for renovations, for old houses. And then there is the third type, which is the load-bearing construction, where the straw bale itself is the brick. So you don't need any structural parts beside the straw itself. And this is kind of the most advanced way to build with straw, because you reduce the gray energy from the whole wood construction too. So, and this is not a new invention. The first load-bearing houses were built in the middle of the 19th century in the United States, because the farmers there realized that if they take the straw bales and they build houses of it, that it keeps you warm in winter and cold in summer. And also in Europe, the oldest frame construction with straw bales is in Paris, in France, and it's now around 100 years old, and you can still go and take a look at it. So it's not a new invention, it was always there. The process started with the invention of the straw bale machine, and then this started. So I'm gonna show you different projects where we tried to realize our vision, and this is the first one, because it's a single house, but the why I show you this is because we could realize so many parts of our idea there. So this is in the Swiss canton of Bern, a single house that is in a small village, where we had now I have to look it up, the State Office of the Preservation of Monuments. They told us that this building has to look like the other buildings all around, and for these houses in Bern have typically really big roofs, and the client, they wanted to have a really open space, a really modern architecture. And so that was at the beginning kind of a problem to get these two ideas together. But we started by doing a simple a ground plan. On one side the garage, on the right side, and on the left side we had a wooden construction, a frame construction that was stiff in itself. So we started with this wooden construction, and then we created elements filled with straw into this wooden construction. Here you see the how do you say in English? The section, exactly. Sorry. We always have this idea of a sleeping bag, or the original idea came from the time in the military, where we had to sleep outside during winter time in a sleeping bag. And the marvelous thing about this, that you can sleep during winter time outside without the heating, and you're warm enough. And we tried to take this idea from the sleeping bag and put it into houses, because the house is nothing different. We are living in it. We have heating, but also by cooking, by showering, etc. You have a lot of heat that goes out, and this is the reason why we have so much isolation. Here we worked with bigger straw bales, so the wall is 80 centimeters thick. But this way you don't need a lot of rest energy, because all the energy that you produce in the house itself is enough to keep the house warm. Here you see this timber frame that we started with the construction. And into this timber frame we put these elements of straw. You see the thickness of them. And just to explain how it works in Switzerland, we as an architecture office, we kind of write down all the work that is necessary to do the work, and then we send it to different companies to give us a price. And for example, they often don't know the price for straw, and then they are unsure about this. But we always get different prices. The prices are really different often, but at the end we always find a contractor that does it for a reasonable price. So this is one of these straw elements. In this case, because the wooden construction itself was stiff, we could leave the straw open, so from the inside and the outside. And we worked in the inside, we worked with clay, and you can use the straw itself as a plaster base. We put the clay on it, and on the outside we worked with lime, because lime is a kind of really are typical, especially in the Alpine region, to work with lime. And lime is water resistant in comparison to clay, which is not water resistant. So we often work with this clay inside, lime outside, and in the middle the straw for the isolation. So you all got all the perfect aspects of clay, which we heard is a really good product. We have the straw, which has really good aspects of isolation, but also the possibility to use it as a brick itself. And on the outside, you have the lime, which is water resistant, but also open. So the whole wall can breathe. And this is also for the living inside. It's really a healthy living because you don't live in a neoprene, but you can the building can breathe. And then you can see this huge roof that we had to build. We took this as a chance, and we started. We covered the whole roof with photovoltaic and solar thermy, but the problem was with this huge roof, still that the clients wanted a really open space and a light-filled house. So we created light shafts on top of it that go through the whole building. You see at the top one of these light shafts, and the ceiling and what was done with we worked with a lot of glass so that the light comes through the whole building. And so the building is really light and modern, even though it has this huge roof. And the building itself, it produces around 6 times more energy than it uses itself. So the CO2 that it emission from the construction part is being built down after 25 to 30 years. Okay. So this is the next project. It's a company called Complimedis in the Swiss canton of Solothurn. This is a company that is specialized in alternative Chinese medicine, and they came to us and they wanted to build or to renovate their factory so that it looks more appropriate to their product. And this is the original building. And they told us that they still want to use the factory during the renovation, so we had to find ways to make this renovation and that they could use the building itself. So we decided to work here, kind of the sleeping bag idea from before again. This time we have a winter coat and a summer coat. The winter coat is made with the straw construction. These are wooden elements that are filled with straw, and the summer coat are the bamboo cladding that you saw, which prevents overheating during summertime, and it's always also a product that is really close to the company itself. You see this is the prefabrication of these elements. This was with a carpentry close to the building site itself. They constructed the wooden frames. This is possible for every carpentry, so this is nothing special. The only special thing for them was to put the straw inside, but this is really not rocket science, so we could persuade them to do this way. And this is a whole wall actually from top to bottom. The idea was that we could take these whole elements and just put them on the facade. Here, this is a picture during construction time. You see the winter, the winter part, or the isolation for the winter time. And here you see the summer coat that is put onto the building. And with this way, we could accomplish all these goals that the company itself told us. They could use the building during the whole construction time. This wouldn't have been possible with other ways to construct the building. So it was, for them, it wasn't even a question if this is more expensive or not, because we could ensure that they could work on during the construction time, and this was their main argument, and not the ecological materials. And at the beginning, it looked the bamboo looked yellow. Nowadays, it's silverish, and it looks actually even nicer than on this picture. Okay, then this is the next project. This was an investor's project in Nennikon, close to Zurich. The idea, it was the client came to us, and they said they want to build. They want to build ecological, but they also want to have a return on capital, and the return on capital should be like the market return on capital. So we had to find ways to ensure that we could build ecological on the one side, but on the other side that we also guarantee the return on capital. So we made different decisions for that. Or one of the main points was, if you build ecological, the architecture has to be as persuading that people are willing to pay more for it, because people are not willing to pay, or often not to pay more just because there is clay instead of something other different. So we have to create a good building that has more qualities than a normal building, and here we tried it to do that. This is the situation of the building, and we put these 3 buildings on the outside of the building plot. So we created an inner courtyard with a lot of different spaces, public spaces. You start from a really public space, and then every inhabitant goes through a balcony access to his flat, and it gets more and more private till you're in your own front of the door, and then your entrance have your own entrance to the house. The idea, there were 2 ideas behind this. On one side, to create a village in a village kind of way, so that every inhabitant has their own house, a door, so he feels that this is really kind of his home, his house. And it's also interesting, people nowadays, they really look after their balcony, they are looking after this, so that was the idea. And on the other side, we wanted to reduce, because the expensive part is always the square meters warm inside the building. So we try to reduce the builded warm square meters. This was the reason also for the balcony access, because this way we could do cheap access square meters to get to the apartment. And we try to reduce and create as few square meters warm living space as possible to reduce the whole costs. And on the other hand, we decided with this structure to be very flexible. So the marketing company, they said how many apartments they want to have, what size they should have, and they always changed minds. So we had to develop kind of a ground floor plan that is flexible, and that you could also change in the last moment. This is the section of the building. You see again the sleeping bag really goes all around, even with the ground floor that we did with a timber straw construction. So also to reduce the cost, again, we decided to prefabricate as much as possible. We not only created wall elements, but we created whole room elements that were prefabricated. And this way you had actually a simple way to build the house. It's kind of Lego, and it helped us that we could work during winter time. And on one hand, and on the other hand, because it was serial, the production was serial, the prices went down. And at the top, we could use the roof to put photovoltaic on them. On these pictures, they were sold, the houses, and they were sold for. They were really fast sold. So after 3 weeks, they were all sold, and this was really good for us because we had the idea, but we were not sure like how is the market gonna see this, and the people were really looking after something like this. And people were also willing, like if you go to the supermarket and you buy a biological apple, you are willing to pay a bit more for the biological apple. And this is kind of the same idea, just with living. And we really had to persuade the marketing company that this is possible, because the marketing company always said this is not gonna work because people are not willing to pay more for this. So this was then during the construction time. We started, or the contractor started with the concrete works, and the same moment we were working on the concrete works, the carpentry started working on the elements. Here you see now some wall elements that they were producing. Here again, just to let you know, we took two times the small straw bales, so 2 times 35 gets to 70 centimeters wall thickness. It's also possible just to do the 35 centimeters. That's also possible. And if you just take the 35, then you also reduce the creation energy, but the consumption cost not so much. But just if you think from an investor's point of view, probably 35 centimeters is more economical than working with 70 centimeters. Here you see one of these elements. If you work with straw, you have kind of uneven surfaces, and the idea, you can also just leave these uneven surfaces and put the cladding on it, or the plastering on it, and you just have the walls that look a bit uneven. It can also be nice, but here the client wished that it's even. So the contractor invented this machine just to cut the straw and get it even. This is one of the ground elements. And for example, the contractor, we wrote to around 25 or the big 25 carpentries in Switzerland. We sent the offer that they should offer, and from these 25 companies, just 5 gave us an offer. And the 5 two were really close to each other, the other 3 were really far away. So we started working with this company. They got their straw from France, not from Switzerland, but Switzerland, the agriculture in Switzerland is really focused on cows and not so much on producing of grain. So it's cheap. Also, Swiss farmers get their straw from Germany and from France. So just. And then here you see these whole room elements that we constructed. The idea was we had to this serial production helped us that the price went down. And then we took these room elements. We took to another factory that we could rent out just for this space. And in this factory we put up all these rooms. And then we sent the other contractors there to do their work. During the same time, the concrete work was still going on. And here you see the plastering. You can use the straw bale as a base itself. So we did this. And we also put inside like all the electrician installations and all the plumbing, the heating, etc. It was all done in this factory. And we also put the underlay in these rooms so that it's dry when it comes to the construction site. And that's the way one of these rooms looked. Like the windows were also already in, the doors were in, and inside was also a lot of the stairs were done, etc. Then we came to the construction side, and then it was really like Lego, putting this whole thing together. And the main goal was to reduce the construction time, and on this way we could reduce the construction time for over half a year. So this was also an argument for the investor that they get the return on capital earlier than with another alternative way to do it. This is still during construction. You see at the bottom still parts of the third house that were built. This one was already a bit further. This is how it looks nowadays. You really see this balcony access gives you the opportunity that everyone lives kind of in a small town where everyone has his own house, and this is also an argument that we could sell the houses for a higher price than if it's just an apartment in a bigger house. And we got on one side, we got the public space, which we tried to close, or as few windows as possible. And on the other side, we open it up completely with light, because this is more public, private space, and people couldn't look inside. That's how it looks now. We could also use the whole roof to do the photovoltaic. And in Switzerland, since for the last 2 years, it's possible now that you can create your own small power plant company, and then you can sell yourself the energy. So we created a kind of a small energy business, and the inhabitants, they sell each other the energy, because some are going outside to work, others are staying at home, and the idea is to maximize your own consumption and to amortize faster the investment that you did. And then the last project I'm going to show you. I think I'm a bit late, but this is kind of a next step project. We tried to see how far can we go with straw. And the inspiration for this came from a travel to Italy. This is in Apulia. They are called tuli houses, where they just use bricks and don't use any timber roofing. They just take here you see it. They just take the brick and always step it a bit more inside, and this way you get a roof. We took this idea and we thought should be possible with straw bale too, because straw is kind of a brick, similar to the stone. And we persuaded this company, which is a gardening company. They had their new headquarters built there, and this is a load-bearing construction. Not the other part was kind of a frame construction filled with straw. This is now load-bearing, so it's important if you work load-bearing that the floor plan is symmetrical. This is really important. Otherwise, you have the weights that come down differently, and then you got other problems. This is the section. The idea was really to create a huge space inside for as low cost as possible. And this is actually really one of the cheapest buildings that we ever did, because it actually worked really good. We started by putting columns into the earth. The idea was also not to damage the ground. And then we start with these window frames. These window frames, they are done. If you put a window on, you have to somewhere to fix it on, and this is the reason we did these timber frames. And around these timber frames, we used the straw bales like bricks. And then it went on first roof, and then every straw bale was around 20 to 25 centimeters more inside. And at the top we put a huge window so that the light comes from the top. And on the outside we did clay plastering beneath the roof, just to be sure that for the Brandschutz, for the fire safety, and we put some corrugated sheet iron on top of it. And this is during construction time. You see the window frames. Then we start with the straw bales like bricks. We put them around, and then you're at the first ground. And here, this is the important part. If you work with load-bearing constructions, here you see the bit more specific. The straw bales are always a bit higher than the wooden construction itself. So at the beginning, you got some air between the two constructions, and then as soon as you put the weight of the roof on top of it, like the straw bales are pressed even more till the floor comes down, and you can fix it, and then it doesn't move anymore, and the straw is really compressed, and you can't get it out of place anymore. And here we worked also with the big straw bales, not with the small ones that you saw before. These are the problem with the big straw bales is they are so heavy that you always use a crane to move them. The small ones are around 20 kilograms. The big ones are around 200 kilograms. So for working with elements, it's much easier to work with the small straw bales. But if you work load bearing, then it's easier to work with the big straw bales. This is the inside. We really wanted to show the construction from the inside. So we put lime plastering inside. And now they also rent out this place for weddings or similar stuff. And top there are the offices. So we created a stair that you can lift up. So they can, here you see the stair is lifting up, so they can rent out this place without people going up to their offices. And there is the toilet and the shower is inside these egg-shaped structures. This is how it looks now. I just want to really say to you, this is really no rocket science. Really, it's an easy way to build. It's nothing complex, and I really don't understand contractors that don't want to do this, because it's the material is cheap. It's a easy way to work, and it's not complicated. And it's like Sigurd said before, it's there, like it's under our noses, and we don't use it. And also the idea, it's there everywhere. So wherever we build, we try to get the straw from the place where we do the building, and this is really the easiest way to reduce the gray energy part of buildings. Okay, so thank you very much for your attention. Thank you.
Paul. Very interesting to see this combination of different biological materials and also the diversity in possibilities. With this seemingly simple off-site prefabrication process, it's very admirable to see how far you have come. We will wait with questions until after the last speaker, which is in this bulk, considering straw buildings. It's Karsten Gjelde. He's an impact investor and house builder, aiming to erect the first Norwegian building using the straw and wood-based building system Eco Cocon, which is a cradle-to-cradle based system, claiming ultra-low emissions using annual flats. So, Karsten.
Thank you very much. Just checking on the clicks here. There we are, yes. So I got 15 minutes, I think, so time myself. We started this process about 5 years ago when we wanted to build a house, and we were rather surprised how little has been done in Norway when it comes to construction and sustainability. So we talked with the Association of Architects, and they helped us then through to Asplan Viak, to Skanska and Snøhetta, which has helped us a lot in this. We had a house completed draw applied for last year, which was unfortunately rejected, so we had to move back to start. The advantages, we learned a lot of this because the first building we wanted to make it more like a symbol building, a tall one, whereas now from all the learnings and going back to start again, we wanted to look more on the cubicle principle, because that is, in terms of insulation and surface, that is the most sensible way to do it. We also wanted to have it at high standards. It's great with clay and hay, but we wanted also to showcase that this is possible for like a more upmarket building, and not just like a very restrained building. So we've been trying to have 3 standards in mind when constructing this: is power house standard, the passive house, and the eco-labeling. This is then the building now in profile from the sides, so you see like the top. This is a sloping property. It's about 11 meters from the road, which is, the road is here, and up to the surface where the house is. So that is putting some challenges. So the way we solve this is to put like the basement and the garage in front, and the building itself in back. We also don't want to move too many masses on the property, but some will have to be shifted. When we started this, we were looking at CLT, for example. We found that the business was focusing very much on moving materials and not always on solutions. Fortunately, we're working close with Sigurdur, and he suggested then the hay solution, which is, when we looked on all the climate statistics and emission, it just knocked out everything else in terms of emission, and made very much sense in this. We also want to a certain degree, look for a close to off-grid principle. And have independence also on the water. Basically have something which is completely independent would be a cool thing. This was pre-war and these situations, but we think in like an overall perspective, to have more independence on each building makes some sense for a society and resilience. We also wanted to have the possibility to have some to live there like permanently, not go out of the building, to have exercise, to have work, to have like a closed ecosystem for that. And we wanted to have a flexibility in the utilization of the building over time. So even if it's cubicle, there is like one central point of support in the building, but apart from that, all the walls can be, for future repurposing, be changed. And then we also been wanting to address it, like the expenses for the construction should be low by using elements and smart solutions. So we're prepared to pay a lot of extra for the planning part, but we hope that the construction part will not be too excessive compared to a similar build. It will be a little bit more expensive, but if that part can be a showcase that is possible to do it within this range. The challenge is also, there is a house today, approximately where the current house is. The current house is located here. We're going to use that basement. It's from 1929. It's not insulated in the wall, so it's already now it's cold. It was last refurbished in the 60s. It's a challenge to get up to the house in the winter, or it's a driveway which we need to clean for snow. We're going to get older. We wanted to have a simple life here. And it's a nice view also from the house, so this is also something we wanted to bear in mind. Here are the eco-cocoons, and they are produced in Lithuania, compressed with 7 tons. For us, a very sensible way of producing. I can talk a little bit about the possibility of using this in Norway, but the way we are, for us, it will be imported. And this is also what we saw, unfortunately, that a lot of the knowledge we had to seek also outside Norway. And again, also thanks to Asplan Viak for a lot of help in a lot of processes, and also directing us into the various perspectives. Yeah, this is just like the layers, which is showcased here for the clay. Outside the walls, we're planning to have PV. Probably will have a light gray color, because a lot of the challenge for our house is the heating or cooling in the summer. The building is going to be too hot, simply. There's very few months where we actually needed heating to it because of the sun radiation. The other challenge was the basement part. As you see here, the basement is in the front, but we didn't want to use concrete, and that was one of the what has taken us so long. Has sometimes we've been hitting resistance that we haven't found solutions which we've been comfortable with. Now we come up with a CLT solution underground with a Swiss engineering company, with membranes on the outside, measurements on the moisture level. It gives a little bit on the restrictions on the way we're using it, but we think this is a cool way to avoid the concrete part. We have worked a lot with concrete. We really wanted to use concrete because there's a lot of advantages, but emission-wise, we didn't solve it too well. So here we see the building from the south. This is the basement where we're driving in with the cars. We have a swimming pool there, which is like counter current, so it's about 4.5 meters long. And then there's an elevator in the back, so we can go have access also later in life. And we like to have many staircases because that's good for movement. This is the Swiss construction company for the timber structures, and which we'll probably use underneath the building. We'll probably use glassopor underneath the pool, which we'll be struggling with how to have like underneath a pool in ground a material. Maybe we'll use cell glass there. We haven't concluded on that, but that might be one material to avoid concrete. The floor slabs, we're using planning to use lignotrend. That is also because they've been used in combination with the eco-cocoon in the past, and it makes sense. The material use, I mean, CLT on like horizontal doesn't make sense. It's too much materials. Here's a lot less material. It's also acoustically, and it's coming in element, and we're filling in with gravel in between to weigh it down. So it's an old. We have it in Norway. The same principle with stubblås leire. So it's taking a little bit from the past of historical experiences. These are the green roofs. So it will be then a front. Over the garage, it will be here, and then we will have a green roof. We think that we have sufficient PV on the walls to avoid having. Originally, we wanted to have a PV on the roof, but we found it was cooler to have it green and also to have a terrace there. And we should have sufficient energy with what it is. So that's the design part. I'm more on the climate and zero emission society, but this from a design perspective, it makes the building look cooler. The driveway has been another challenge to find a way to do that. We would like to have it carbon negative. We would like to have it permeable. This is per se, it's not permeable, but it's carbon negative. It is based on lignin, replacing the bitumen in the as a binding material between the gravel. And it's a Norwegian company, so that's a cool thing. We would like to have some food production. We originally had planned for like an 8 square meter room. Now we will have that as a part of the staircase, so we will show it. We have some challenges there because we cannot put it all the way to the CLT wall underground. But anyway, we will live with that. So it's being designed a little bit differently. But the point was to produce some of our nutrients ourselves, and also reuse some of our urine to plant nutrients. That is more like a cool thing because we will just be a few people living there. But it's a principle of like reusing everything on site. We're trying to minimize the level of technical installations. We think that the tech solutions that have been designed by the suppliers industry, we would like to see what is. We wanted to have like all natural ventilation and have been working on several concepts on that. Now we're probably ending up with a hybrid, but we can take in cold air from the basement level and then ventilate it on the top of the building, and it's 5 levels, so there will be sufficient elevation to do it. we will have geothermal. We calculated we could nearly go away from that. On one point, we were looking at deep geothermal, like 1,500 meters, which is bringing water at 32 to 34 degrees. It's not too expensive. It could be worth it, but we just didn't need all the energy. So if you're making a big building, it makes a lot of sense. But for us, we will manage with less, and we will actually need the water also for cooling. We might have 2 wells. We haven't decided. And we'll have also the cooling will be in the walls, so waterborne in the walls, simply to keep the temperature low during the summer. It's going to be warm. And then we have a garden shed in the back. We have been looking a lot on recycling of material. It's really challenging for a single house to do that. Because you need a planning horizon, you need to block off the materials, keep them on storage, etc. At the end of the day, what we'll probably do, this is a garden shed of about 20 square meters, which will have an office insulated and a shed. And we'll probably try to reuse most of the materials from our original building. And then there was a little bit question from Sigurdur, is also how can we bring this to Norway instead of having the materials delivered from the Baltics? To be very frank, I'm not too positive on Norway and climate. I used to live abroad for many years. I was very proud of my country. Now I'm getting more and more embarrassed. We have, like, politically, we have not decided to reduce the emission. We have kept them like flat for the last 30 years, whereas EU have been reducing them. I don't see the building industry taking too much responsibility. It's something here and there. There are some good solutions. We have a lot of advantages here. We should have all the optimal solutions for doing it. We have a lot of hay in Norway, but getting that into production needs more demand. It needs that the industry and people paying for the construction is actually demanding it. So I'm not sure. I don't know where we want to go as a country. I think, like in Norway, we have too much focus on having a nice time, koselig. That's the most important part. And if you put that onto, like, doing something new and changing your lifestyle, koselig is always winning. So that's my take on that. And yeah, it's unfortunate. And then a big thanks to the people who have been helping us. We have had altogether about 35 architects, engineers, specialists into this. When we started, we had with Snø, I think we had like 15 people in, like, and one day seminar on like a single house. So that's it's been a challenge. We learned a lot, and we feel like now we have come to solutions which we are happy to follow on. Time-wise, we have notified the neighbors, so hopefully we will send the application to the municipality next week or something, and then we'll see and take it from there. If anyone would like to contribute, like building the house, entrepreneurs or something, we are in dialogue with some, but we're open to suggestions there and some contact as well. So that's all for me. Thank you.
We would like to have now a short discussion with Paul and Karsten on the possibilities and the disappointments of building with hay, and just one sentence to you, Karsten. You may be embarrassed being a Norwegian, but you cannot imagine what's being Icelandic. So, Paul, would you care to join us? We were thinking of. I know that Terje did not like us to sit; he wanted us to stand. But I think we'll try to do the sitting anyway. Is that okay, Terje? Okay. We got to actually just to start from behind. We got one good question from the net, which was we'll put to you or two actually, Paul. That are there any limitations on what kind of corn you can, what you can harvest to use in hay in buildings?
No, in principle, you can use rice, bygge. Yeah, in German, Hafergerste, Mehl, Roggen, and in Norwegian, Hafer, bygge, Hvete, ruk. So this is all possible, but the important thing is that the straw doesn't have any nutrition anymore inside. That's a bit kind of, because you always, I'm not sure if it's a translation problem, but if you talk about hay has nutrition parts and straw doesn't have nutrition parts. So it's really important not to use hay. So you need to use straw. Otherwise, you get animals can get their food from it, and this is important that this is not the case. But if you work with straw, you can use the different varieties of straw. It's just the nutrition part is important, that it doesn't have nutrition.
So it's that's a good thing. Then we're not like starving the sheep or the cows in order to build homes.
No, absolutely, because the straw isn't used to to give food to the animals. It's mostly used for farmers to clean up their the mess of the cows. So it's not, they don't use it to eat or anything. So it's a byproduct that no one else uses beside the farmers.
So actually, we could use the Norwegian straw in the same way as you use it in Switzerland. The second question was quite good. If you have such thick walls, do we need, like for the internal walls or external walls, do we need any extra, like acoustical layer? Or if we have such a thick wall, can you comment on the acoustical qualities?
In Germany, I saw once results from this test, and they are actually good. They are really good. So for the outside, it's no problem. Yes. In the inside, it doesn't make so much sense to use straw bale walls inside, because you spend a lot of money for the roof and for the foundation for the square meter of straw wall. So that doesn't make so much sense. So we really try to reduce the outside walls as much as possible to get the cost down, because we are playing in a market where people they are not willing to pay 50% more for a house that is built this way, but maybe they are willing to pay 10% more, and we really try to focus on these 10%. We try to reduce wherever it's possible the cost, and that in comparison, for example, the project you explained, the architecture is really complex, and complexity costs, and we try to reduce complexity as much as possible to reduce the cost. And this is also kind of the reason why our buildings often look symmetrical, easy to place, and they are not randomly, seldomly not symmetrical. This is just the reason to bring the cost down.
Paul, could you say something about the market situation for straw bale houses in Switzerland today, and also maybe a bit of how you see the future of it?
Yeah, our office was actually the first one that built a straw bale house in Switzerland, and it was in the media, they showed it and stuff, and then some others also started with it, and we are really appreciate this, because we don't want to be the specialty guys. We actually want that it becomes really common. But like on the European focus, I would say, especially in France and in Germany, they are even further. It's especially from the government side, it's subsidized much more, and the government has much more interest that it's going to build this way compared to Switzerland. I know maybe a German looks, but compared to Switzerland, yeah.
I have one question to Karsten. The Norwegians, they do not import gas or oil. They use their own. And now from this fantastic product, EcoCocon, which we have two things of here, in Denmark, we now have an entrepreneur who is building EcoCon with there. So if we would have one module builder in Norway, Modulbygg AS, just to pick something which sounds like it, if one of them would say, I'll give it a shot, we will just go for this one, and we would just get the straw from the locals. Wouldn't that be great?
It would be great, yes. It's a short answer, yeah.
Yeah. And I remember when I came to Norway 12 years ago, Passive House was just like a drama. People would suffocate, you wouldn't get any air, this would be too expensive. And today it's just like blå skismøring. Like everybody's using it, or now you're not using it under the skis anymore, but sorry about the ski jokes. So I actually think the Norwegians, they are quite adaptable, despite being so hyggelig. And so do you think that would be, if you would just put a thumb in the air for this fantastic fabric for massive timber from Splitcon? I remember reading they needed 250 millions to build the fabric. I mean, do you think, Paul, that we would need 250 million, that would be 25 million euros, to start up a fabric for a module here, or could we just use like the modulbygger which we have now, and they just put hay instead of glava?
I think these are two different approaches: the top to bottom or the bottom up approach. And I think the top to bottom approach is, from my point of view, the wrong one, because all this knowledge, these resources, they are already here. And we often go to, if there is a carpentry in the village, we ask them if they were willing to do this, and then we try it, and then if they see that this is going to work, they are willing to do this. And now we got a kind of a network in whole Switzerland where we also, with bigger carpentries, we know that they are willing to do this because they know it works, and we do it this way. But I think this is much easier if you start at the bottom and go up than if you start at the top and you go down, because the barriers are much higher if you start top to bottom than if you start bottom up.
I completely agree. We're also investing in several companies, and also what we see is when you start with finding solutions, finding market, getting experience, getting showcases, and then taking it up. It doesn't cost money, but you need a compressor to press it down, and you need some wood elements, and you need some good carpenters, and a few people. That's it, and then you can start producing it. You need also drying facility for the straw.
Have you been out in the Norwegian market to see if it's any interest?
We have been working with Kreatera and EcoCocoon because they have a plug-and-play solution for us, and they have long experience. So that's the simplest way for us.
We have two questions now from the public. Just so, and then we have the pause. So can we just have the first one?
Ja, den er på. So just briefly, you said it was hard being from Norway and seeing this, and Iceland. Then try to be a civil engineer from Denmark, specialized in straw and clay, and living here 10 years. That's me. I am the local partner of the EcoCon. So talk to me about that, whatever. I wanted to add that in 2015, 2 straw bale houses were built here where we had to import straw. It got imported from Poland because that's where they had the contact instead of Denmark, Sweden. It's simply because straw gets wet sometimes and you can't really trust such circumstances. So you need to plan ahead. It takes often a warehouse. Farmers, the straw they save for the animals. What they don't save usually stays in the field, gets plowed down, or in Denmark they start burning it, which is better than burning all of your trees from Norway, as we also do. So that's one issue. Another issue is...
To the question?
Yeah, it's about the certification. That's really hard to get on the market. Currently, we have 15 companies in Europe making panels like the one you see there in front. And it takes a lot to get there. And I don't know how you manage that in Switzerland. Because there you take random bales. In Germany, you get certified the bales in order to have them in the right quality. Because a bale is not just a bale. Some bales are a real mess. Our panels, we don't use the bales, we mess them up so there's not a cold bridge in them. There's a lot of knowledge in it, which I'm wondering, how do you manage this whole certification process? And by the way, I'm really grateful for the update. I've been following you for 20 years, and your dad is a big hero of mine. And he started with big bales. Yeah.
Yeah. Thank you very much. This is really an important question. We get this, especially if we work in Germany or Italy, we got the same problem. But in Switzerland, we don't have a certification. Like, you can use whatever you want. The government doesn't tell you which way you have to comply with the rules. But the way you build the house, that's up to you. And you don't have an engineer who checks if this is gonna work or not. It's like it's up to the people who build the house. They have to take the guarantee for the building and not the government or anyone else. So for example, we were lucky because my grandfather had a building company, and we started doing our experiments, and then we saw this is gonna work. So we were brave enough to try and do it. But yes, on the other side, if it wouldn't have worked, we would probably, our office wouldn't be here anymore. That's true, yes. But it takes some risk. But now we did it, so we can tell you it's possible. So that's the good part.
Thank you, Paul. I think we have one more question, right?
Yeah, just a question for Paul again. It's just a follow-up on the cocoon stuff. If you start from the bottom, let's say go to a farmer and ask, do you have some straw bales for me? I'm sure, I understand it's like moisture content and fungi. Obviously, it's the thing, and you dry it out. So the dryness is important. But what requirements do you have when you do from the bottom scheme?
Mm-hmm. There is even a German norm for it. I don't know the number of it exactly, but it specifies exactly what it's needed. But the important thing is that it is dry. Yes, this is probably the most important part. But you often just see this by looking at it. So if it's golden yellow, then it's okay, and if it's gray, then you know it was wet at some time. And you can also measure it with a like you measure the wood, you can also measure the wetness of a straw bale. And if it's about 12 to 15% humidity, then that's no problem.
I suggest that we continue the discussion in the pause. And thank you for excellent lectures. Thank you for clever questions, and looking forward to a good pause and then to continue. Thank you.